Hello, I am Dr. Habib Ahmed, Assistant Professor in Mathematics, Government Women's First Grade College, Jawargi Colony, Kalaburgi. So today's lecture on session 9 of BSc 5th semester, that is paper 5.3. So today's topic is basic recurrence relations. Show that the following results. First result is Pn of 1 is equal to 1. Second result, Pn of minus x is equal to minus 1 raised to n Pn of x, and hence deduce that Pn of minus 1 is equal to minus 1 raised to n. Third result is P dash n of minus 1 raised to n is equal to minus 1 raised to n minus 1 into half n into n plus 1. So we start the solution of these problems. First we shall consider the generating function. So here generating function is given as 1 minus 2xz plus z square whole raised to minus half equal to sigma n runs from 0 to infinity z raised to n Pn of x. Here mod x is less than or equal to 1 and mod z is less than 1. We call it as equation 1. Now we start the solution of first problem. So we call it as solution 1. Here we put x is equal to 1 in equation 1. We get simply, so replace x as 1 here and simplify, which gives to equation 1 minus 2z plus z square whole raised to minus half, which is equal to sigma n is equal to 0 to infinity z raised to n Pn of 1. That is, so this is the expansion of a minus b whole square. Square with minus half get cancelled. So result is 1 minus z raised to minus 1, which is equal to sigma n runs from 0 to infinity z raised to n Pn of x. Now we expand this one. This LHS, expansion of this LHS is 1 plus z square plus so on, plus we write now n term as z raised to n, again next term so on, this RHS as it is. Now we call it as equation 2. Now equating the coefficient of z raised to n on both sides in equation 2 we get. So in equation 2 z raised to n is here. Now coefficient of this quantity z raised to n is 1. So we have written here 1. Next equal to as it is. Now here is z raised to n. Its coefficient is this quantity. So Pn of 1. So this is the first required result. Now we move on to second solution. So here we replace x by minus x in equation 1 we get. So this gives to equation 1 now becomes 1 plus 2xz plus z square whole raised to minus half, which is equal to sigma n runs from 0 to infinity z raised to n Pn of minus x. Now we call this as equation A. Again replace z by minus z in equation 1. So we get 1 plus 2xz plus z square whole raised to minus half equal to sigma runs from 0 to infinity minus z raised to n Pn of x. We call this as equation B. Now from equation A and B, see here equation A LHS and equation B LHS, both the LHS are same, so these two RHS must be equal. So therefore now we write as sigma n runs from 0 to infinity z raised to n Pn of minus x is equal to sigma n runs from 0 to infinity minus z raised to n Pn of x. Again this one we are written as it is, now equal to sigma n runs from 0 to infinity. This now minus 1 we take, or we rewrite this as like this. Now this minus z raised to n can also be written as like this, z raised to n into minus 1 raised to n Pn of x. Okay. Now equating the coefficient of z raised to n on both sides we get. So now here coefficient of z raised to n is Pn of minus x here equal to, now z raised to n is here, coefficient is this one, we are written minus 1 raised to n Pn of x. So again we take or put x as 1, we get here. So Pn of minus 1 which is equal to minus 1 raised to n Pn of 1. But we know that Pn of 1 is 1. So therefore this again this equation now reduces to Pn of minus 1 which is equal to minus 1 raised to n, which is the second required result. Now we move on to third result. So solution 3. To prove the third result, we start with like this: Legendre polynomial Pn of x satisfy Legendre's equation. So therefore this is the Legendre's equation: 1 minus x square y double dash minus 2x y dash plus n into n plus 1 y equal to 0. We call it as equation 1. Therefore we have 1 minus x square, we replace now y as Pn of x. So P double dash n of x minus 2x P dash n of x plus n into n plus 1 Pn of x equal to 0. We call it as equation 2. Now putting x is equal to minus 1 in equation 2, which takes the form, see this equation 2, 2 p dash n of minus 1 plus n into n plus 1 Pn of minus 1 equal to 0. Next we use this results, Pn of minus 1 is equal to minus 1 raised to n in above equation. So this one we replace as now minus 1 raised to n. So this side 2 p dash n of minus 1 plus n into n plus 1 minus 1 raised to n equal to 0, or first term as it is. Now we shift here other side, so this take minus n plus 1 minus 1 raised to n. So therefore this one p dash n of minus 1 is equal to, we shift to here this side, so it is 1 by 2 n plus 1. This minus 1 raised to n simplifies to this quantity, minus 1 raised to n minus 1, because see here, minus times minus 1 raised to n is equal to minus 1 raised to n minus 1. So here this is the third required results. So here we have used the book as G.K. Ranganath, 5th semester, and Dr. Higher Engineering Mathematics by Dr. B.S. Grewal.